of triangles. There are going to be some questions on number 1. Obviously, we know that that's a non-calculated figure. And you're going to be asked about solving trig equations or has trig functions in there somehow. And you need to know the values of them. Which means that you need to either learn the values that we're going to go through in a minute, or make sure that you remember the method of finding them, okay? Okay, right. First things first, we're going to focus on this triangle here. This is an equilateral triangle. Doesn't look like what it is. Okay? So that's an equilateral triangle of side length 2. I split this one into 1 and 1 because what I want to do is cut it into 2 halves. And there I've got a right-angle triangle. You happy with that? So it's an equilateral triangle of side 2 cut in half. I've now got this right-angle triangle. Now, remembering that this was an equilateral triangle, what do I know about this angle here? There. That's equal to 1. And so how much is it? 60. Why is it 60?
Maybe divided by 3.
Good. Are we happy with that? So that's a 60-degree angle. What does that mean that this angle up here is going to be? Careful, because we've cut it in half. This one's going to be 30. Yes? Alright, now, the only thing we're missing now is this side length. How can I find that side length? Not SOHCAHTOA. Because remember, this is a non-cap figure.
Oh, it's equilateral than 1. You could add them together.
It's equal to the one. I was trying this length, sweets. What? I don't know what you're trying to tell me.
Pythagoras.
Pythagoras, yes.
Pythagoras.
Well, I think we can refer to the recording. Yeah. They will not do that. How do we find that length? What do we do?
A squared plus B squared.
A squared, A cubed. A plus, can someone tell me some numbers, please? No, A squared plus, no, just one person. 1 plus 4. What?
Where the heck you go?
2 squared minus 1 squared equals length. Okay, lovely. Skylar, why are you telling me it's subtract?
Because it's always the hypotenuse. If it matches the hypotenuse, then it's a subtract.
Good, because we give them this length here, which is the hypotenuse. To find the short side, it's going to be subtraction, yes? I've got the square root sign in there because I want to find just the length of it. So what's 2 squared? Take away 1 squared, which is 3. So I'm going to say that this side length is root 3. Okay? Yes? I'm going to keep it as root 3 because we haven't got a calculator and can't actually find the value of that. So, are we all happy that this is root 3? Alright. Let's talk about this triangle here then. This one, what kind of triangle is this? This length is 1, nice. This is an isosceles triangle. I need to know this length and I need to know these 2 angles. Let's deal with the angles first of all. What do I know about these 2 angles? This is an isosceles. Yes, they're equal. You're not shouting out. 45! Yes, they are. 5 the additional shell. Yeah. And now we need to find this length. How are we going to find this length? I'll give you a clue.
Pythagoras. You add A squared plus B squared equals C squared.
Okay, so
1
this one is
squared plus 1 squared.
nice.
Math.
Wait, so what's 1 squared? 1, and so this is going to be root 2. Yes, gladly. Why is this one plus? Yeah. Because this, which side is this one? And which side were we trying to find here? The short side, yeah? So because this is a short side, that's why that was subtract. Because this is the hypotenuse, it was add. Wait, why is that going to do that? because it's 1 squared is 1 plus 1, so it's the square root of that. They're always going to be the square root of, because it's a squared plus b squared equals c squared. So to find c on its own, you're always going to be square rooting at some point.
So the other way is we add 1 squared plus 1 squared and then equal and then
Yes, so I'm just trying to do it all in one. Yes?
square root of 1.
Yeah. Because 1 multiplied by 1 is 1. It's 1.2, so that's pretty. It's irrational.
Yeah, so the adjacent like one, that would be plus as well.
If I was trying to find any
Wait, no,
I
take away.
if I was trying to find either of the short sides, it would be subtracted.
Okay.
Okay, so are we good? Are we good with that triangle? So this one was. This was a. Oh my gosh. I'm just gonna play this for your parents and say this is one.
Say this for Olivia's family.
So this was an equilateral triangle. We were able to establish there's two angles, one of 60, one of 30. This one is, they're both 45. Now, this is where your SOHCAHTOA comes into play to help. I think what I'm going to do is I am going to just redraw this, and I'm just going to mark on one of the angles, okay? So I'm going to redraw this triangle, and I'm just going to show the 60-degree angle to start with. If I was going to label HOA, which would be the H? Which would be the O? Careful. Roofing. And the A? Okay. So if I was going to talk about the sine of an angle, if I was going to talk about the sine of 60 degrees, okay, the sine of 60 degrees, we know that sine is what over what? So for this question, the sine would be what over what?
Root 3 over 2.
Yes? Opposite over hypotenuse. So here, I would say here, root 3 over 2. Because if the angle was 60 degrees, then the sine of 60 would be root 3 over 2. You happy with that?
No.
You think no?
Show the song.
So here's my angle, 60 degrees. If I was trying to find the sine of 60, it's always the opposite length divided by the hypotenuse. So that would be root 3 over 2. Okay? So if I were to put this number here in a calculator, root 3 over 2, and inverse sine it, so sine to the minus 1 of that, I would get the number 60. I would get the answer 60. Okay? So we need to recognize values like this. So when there's root 3s and root 2s, it's going to probably be an answer of 30, 45, or 60. Okay, this is what we need to try to become familiar with. Right, that's the sine of that angle. We're now going to look at the cosine of that angle. So again, we're looking at this column. So the cosine would be car, yes?
Yeah.
Cosine is what over what? And for this one, it's now, maybe just check the Shelby's with this. So the cosine of this would be what over what? So tell me some numbers.
1 over 2.
So in my cos column, I'm going to write 1 over 2. Again, if you did the inverse cos of 1/2, you would get the value 60. If you're not really believing me, feel free to try it. Yes?
In the box, when it says pi over 3, is that just equal?
Yes, I'm going to talk about that a little bit. I wanted to just do it in one table because otherwise you're going to draw two tables and then talk about radius in a minute. And last but by no means least, we're going to look at the tan. So tan is TOA. So Jennifer, you said you were not 100% sure. So this time we're looking at which over which? TOA?
Over A.
Yeah. So tell me some numbers.
Square root of 3 over 1.
Yeah. So in other words, it would just be root 3. Yes? Now, At this stage, you're probably thinking, well, how on earth is... Oh, no, let me stop.